To find the formal charges for each element in ClO2-, the chlorite ion, we'll use the Lewis structure here and this formula. So let's start with this oxygen right here. Oxygen, that has 6 valence electrons. It's in group 16, sometimes called 6A on the periodic table. So we have 6 valence electrons for the oxygen, and we're going to subtract the unbonded valence electrons. 2, 4, 6 unbonded valence electrons. And then we'll subtract 1/2 of the bonded valence electrons. These are the bonded valence electrons. They're between the atoms. They're forming the chemical bond. They're shared electrons. So we have 2 of those there. We have 6 minus 6, that's 0 minus 1. That gives us a -1 formal charge on this oxygen here. Let's take next a look at the chlorine atom. So for chlorine, that's in group 17, sometimes called 7A on the periodic table. It has 7 valence electrons. We'll subtract the unbonded valence electrons. We have 2, 4 of those. And then we'll subtract the bonded. And then we'll subtract 1/2 of the bonded electrons for the chlorine. So we have these 2 here, 2, 2, so 2, 4, 6. 7 minus 4, that's 3, minus 3, that's 0. So the formal charge on the chlorine here, that is 0. For the last oxygen, which is different, it has a double bond, whereas this one has a single bond. So for this last oxygen with the double bond, we have oxygen, group 16, 6A, 6 valence electrons, minus the unbonded, we have 2, 4, minus 1/2 of the bonded valence electrons. We have 2, 4 of those, and that equals 6 minus 4, so that's 2 minus the 2 here, that's 0. So the formal charge on this oxygen is 0. And all of these formal charges, they add up to a -1, which is the charge on the ion. This compound does have a resonance structure where you'd have the double bond on this side as opposed to over here. But again, you would use the formal charges. You'd have the 0 on the double bonded oxygen and the -1 on the single. So those are the formal charges for ClO2-, the chlorite ion, and this is Dr. B. Thanks for watching.